Hi, I'm Chow Yi-Xiang, and I will be presenting on the functionalities of Amazon Textract and Amazon Translate, which are using to extract text from photo or pictures and translate it into the language that requests. So now I will show the demonstration of these functions. For example, this is the picture that we want to extract the text and translate it into German language, and the origin language is English. Before we start, take a look with the Python script. And the Python script will request for some input, the account ID, which means email to identify the user, and the S3 bucket name, which store the documents and the documents name, and the origin language, and the targeted language. Here are those language that supports in Amazon Translate. And here is calling the Boodle tree. The Boodle tree is the AWS SDK for Python, and it get the Amazon services. And here is the text track. It get the functions. And here show the output of the extracted text. And here show the DynamoDB parts, and it's put the extracted text into DynamoDB for future work. And here is the translation part. And now we take a look with the result of the Python script. As we can see, here is the input that we talked about before, expensive PNG, and here is the result of the extracted text. Although it's in table form, it's able to extract according to the column and row. So here is the translated result in German. And lastly, we take a look with the DynamoDB. Here is the extracted text that we extracted before and inserted it into the DynamoDB. Thank you. That's all.
My name is Goh Yung Zhuang. Now I'm going to talk about Amazon Lex. Amazon Lex is a service for you to create chatbot. First, create a bot, but I'm going to show you the one I have created here. Here you could create an intent which is actually an action. In an intent, there will be sample utterances where you could train your chatbot about the input. All these inputs will trigger this intent action. Next is the Lambda initialization and validation. Lambda is a service for you to run your code without thinking about servers. This Lambda function is going to be called each time this intent is called. You can include validation and data processing in the Lambda function. Next, talking about the slots. Here is where you prompt your questions for the data you want. Here, I ask for the location, check-in date, nights, and the types of room. Once all the questions have been answered by the users, the confirmation prompt will be prompted to get the confirmation from the users. Once confirmed, it will go to the fulfillment, whereby here I choose the same Lambda function to process the data received above. Here you can choose the response when the intent is ending. After you setting, you click Save Intent, then you build and publish this chatbot. Next, speaking about channels. Here are the lists that you can integrate this chatbot to other platforms such as Facebook, Kik, Slack, and Video SMS. For my case, I have implemented Facebook. You need to add this callback URL to the Facebook API for Facebook to access this chatbot. Next, I'm going to show you the Lambda function. Here you need to create the Lambda function, and I'm going to show you the one I have created here. And this is the code to handle the Lex intents, which is written in Python 2.7. I have uploaded this code into Google Drive, here stated in the report for the links. In this code, I added save to DynamoDB after the intent is completed. DynamoDB is the NoSQL database service provided by Amazon. You need to change the AWS access key and secret access key to your own DynamoDB keys. Remember to save your code. Next, I'm going to show you the data saved in the DynamoDB. Here is it. All the data will be saved in this book hotel table. Thank you, and that's all for my part.
Hi, Dr. Cheng and my fellow classmates. I'm Dan Sime. I will be presenting Amazon Summarian integrated with Amazon Lex, which provide an augmented reality environment with a hotspot. So this is the dashboard of the Sumerian browser-based authoring tool. The step to be done for this scene is presented in the user manual. So we'll now test does it work. Click to publish and then copy the link.
Hello, my name is Christine. I am a Sumerian host. How can I help you?
So when you want to speak, you press the spacebar, and then when you finish speaking, you release the spacebar. Book a hotel.
What city will you be staying in?
Chicago.
What day do you want to check in?
Today.
How many nights will you be staying?
2.
What type of room would you like? Queen, king or deluxe?
Deluxe.
Okay, I have you down for a 2-night stay in Chicago starting the 14th of April 2020. Shall I book the reservation?
So this is the voice version. So next we'll proceed to text input version.
Hello, my name is Christine. I am a Sumerian host. How can I help you? What city will you be staying in?
So basically the difference is you key in the text box and the flow is same as the voice version. So to save time, I will stop here. So with that, I have finished the Sumerian AI demonstration in our project.
My name is Danny Fu, and now I will be presenting the blockchain service. The blockchain service is used to track the reward point movement for data analysis and user loyalty and purchasing behavior. Demonstration will be done through the manual report. Firstly, we have to create a new environment for AWS Cloud9 for configuring blockchain. Then the network will be created with a small peer node. Next, the client node is created to host Fabric CLI for administration purpose. After that, channel is created on the client node. Channel is a private subnet of communication between two or more specific network members for the purpose of conducting private and confidential transactions. Then, the peer node is joined into the channels. Chain code is installed and initiated at the peer node to enable the interaction with the network share ledgers. This is the example of query on dummy data from the share ledgers. First query retrieve reward point from user A and 19 points are returned. Second query deduct 10 reward point from user A and transfer the point to merchant B. The deduction is successful. Third query again retrieve the reward point from user A and this time 18 points are returned because 10 points are deducted from the previous transactions. Moreover, we can also monitor the point transactions, CPU and memory utilizations of the network. With that, I have finished the blockchain's demonstration in our project.